All right, very similar question to number 8, but this time we do have an angle. So we have radius times force. If it's not perpendicular, then we multiply by a sine of the angle for basically the misalignment. So if the force is perpendicular, that's the maximum amount of force the most directly can be applied. You get maximum torque. But if your force is misaligned, then you start losing torque because well, you don't have good connection. So 45-degree angle, that's our theta. We've got our R up here. We don't have a force. So like last time, we want to go and multiply by gravity. So we can find the weight of the child so we can see how much force they put on the board of the seesaw whenever they sit down. All right, so that's going to be 303.8 newtons now that that's been converted, so I don't need this thing anymore. Also, I can see now where everything's going to line up, so I'm much happier with this. All right, so this radius, this leverage here, 1.82 meters. The force was that converted mass to weight for the child. And then sine of 45 degrees. So for the 45-degree angle we had. We haven't done any trigonometry in a while, so hopefully you remember how your calculator requires you to type those in. 45 degrees is also a special angle, so if you really had to, you could just Google sine of 45 degrees. It's a number that's widely known and easy to find, but hopefully you're just comfortable with your calculator. The units aren't going to be any different. We have newtons times meters, and then running the numbers through. If we didn't have the angle, then multiplying 1.8 and 300 and something would give us an answer like, I don't know, 550, 600, something like that. But the fact that we do have this angle means that it's going to be scaled down quite a bit. So 390.97.